A-Level Statistics, Combinations. Combinations are groups selected from a larger group where the order does not matter. Suppose we've got 5 letters A, B, C, D and E, and we want to select 2, but the order they're selected in does not matter. The selection AB is the same as the selection BA. Then we have AB, AC, AD, AE, BC, BD, BE, CD, CE and DE. Each of these is called a combination. The number of combinations in this case is called 5C2. 2 letters were selected from 5. Now if our objects are selected from n objects and the order doesn't matter, then we say the number of combinations is NCR. If we select R objects from n but keep the order of selection, then we have a permutation. So the number of selections is n factorial over n minus r factorial. If we now ignore the order, there'll be r factorial selections that would be the same. So the number of distinct selections or combinations would be n factorial over r factorial times n minus r factorial. So we have the formula NCR is equal to n factorial over r factorial times n minus r factorial. Now we also use a large bracket containing n over r to mean exactly the same thing as NCR. It's just an alternative notation. Now there is an NCR button on most scientific calculators. It's worth finding where it is on yours, as it makes working out combinations very quick. Let's have a look at an example. In part A it asks, how many ways is it possible to select 7 children from a class of 7 boys and 9 girls? Well, to solve this, we want to select 7 children from a class of 16, which is 16C7, or 16 factorial over 7 factorial times 16 minus 7 all factorial, which is 16 factorial over 7 factorial times 9 factorial. Now we can write that out in full, and then a lot of it cancels. And that leaves us with 11,440. Or we could have got this by using the NCR button on a calculator. We need to type in 16 NCR 7 equals, and that gives us an answer of 11,440. Now in part B we're asked, from the same class, how many ways is it possible to select a group of 4 girls and 3 boys? To select 4 girls from 9 and then 3 boys from 7, we have 9C4 times 7C3. Now we can work this out straight on a calculator, or we can write out this is 9 factorial over 4 factorial times 5 factorial times 7 factorial over 3 factorial times 4 factorial. Well, we can write that out again in full, and we can cancel, and lots of it cancels. And this leaves us with 4,410. So there are 4,410 selections. Let's have a look at a different problem. How many different ways can a team of 7 be selected from 5 girls and 6 boys, so there are at least 3 girls in the team? Well, to solve this we've got to consider 3 cases. There could be 3 girls in the team, there could be 4 girls in the team, or there could be 5 girls in the team. That is the maximum number of girls available. So let's consider the case where there are 3 girls and 4 boys. Now it's 3 girls out of 5 and 4 boys out of 6. So that's 5C3 times 6C4. And using a calculator, that's 10 times 15, which is 150. If we have 4 girls, we then have 3 boys, so that's 5C4 times 6C3, which is, using a calculator, 5 times 20, or 100. And if we've got 5 girls and 2 boys, that's 5C5 times 6C2, which is 1 times 15 or 15. So if we put the 3 cases together, there's 150 plus 100 plus 15 different arrangements, which is 265. So the number of ways the team could be picked is 265. In another example, a committee of 6 is selected from a group of 6 men and 8 women. In part A, how many ways can the committee be selected? Well, we must select 6 from 14 in any order. So that is 14C6, which we can work out on a calculator as 3003. So our answer is 3003 ways. Now in part B, we're asked, how many ways can the committee be selected if there must be at least as many women as men? We need to consider 4 cases. There might be 3, 4, 5 or 6 women on the committee. So if we've got 3 women, then we'll have 3 men. Now that's 3 women out of 8 and 3 men out of 6. So that's 8C3 times 6C3, which is 56 times 20, or 1120. 4 women and 2 men will mean 8C4 times 6C2, which is 70 times 15, which is 1050. If there are 5 women, then there'll be 1 man, and so that's 8C5 times 6C1, which is 56 times 6, or 336. Or there could be 6 women and no men. That is 8C6, which is 28. Now we can add up the 4 answers. 1120 plus 1050 plus 336 plus 28 is 2534. And so there are 2534 ways that the 6 people could be selected. Let's have a look at one more example. A boy can select 5 film DVDs to take on holiday. He can select from 4 science fiction, 2 detective and 6 adventure films. How many different selections does he have if there are no restrictions? Well, with no restrictions he wants 5 out of 12 films. So that's 12C5, which is 12 factorial over 5 factorial times 7 factorial, which we can work out on a calculator as 792. So there are 792 different choices that he has. In part B, he does not want to take a detective film. With no detective books, he wants 5 out of 10. So that is 10C5, which is 10 factorial over 5 factorial times 5 factorial. But if we type in 10C5 in the calculator, we get 252. So there are 252 possible selections that he can choose. Now in part C, he wants at least 1 of each. Now, if he's going to choose 1 of each, then he can select either 3 science fiction, 1 detective, and 1 adventure film. Now that's 3 out of 4 science fiction, so that's 4C3, 1 detective is 2C1, and 1 adventure is 6C1. That's 4 times 2 times 6, or 48. He could choose 2 science fiction, 2 detective, and 1 adventure. And that's 4C2 times 2C2 times 6C1, which is 6 times 1 times 6, which is 36. He could choose 2 science fiction, 1 detective and 2 adventure. That's 4C2 times 2C1 times 6C2, which is 6 times 2 times 15, or 180. He could choose 1 science fiction plus 2 detectives and 2 adventures. And that's 4C1 times 2C2 times 6C2, which is 4 times 1 times 15, that's 60. Or he could choose 1 science fiction, 1 detective and 3 adventures. And that's 4C1 times 2C1 times 6C3, which is 4 times 2 times 20, or 160. And those are the options that he has. So totalling them up, we've got 48 plus 36 plus 180 plus 60 plus 160, and that comes to 484. So the number of possible selections is 484. Now we've covered quite a lot, so remember, these are the important results. The number of ways of arranging n distinct objects is n factorial. And n factorial is n times 1 less than n times 2 less than n down to 3 times 2 times 1. If we have n objects but some of these repeats, then we divide n factorial by r factorial for each set of repeats. So, for example, the word remember can be arranged in 8 factorial over 3 factorial times 2 factorial times 2 factorial ways, because there are 8 letters overall, and E appears 3 times, R appears twice, and M appears twice. Now, if R objects are selected from n objects in a particular order, the number of arrangements, or permutations, is equal to NPR, where NPR is equal to n factorial over n minus r factorial. If R objects are selected from n objects in no particular order, the number of arrangements, or combinations, is equal to NCR, where NCR is equal to n factorial over r factorial times n minus r factorial. And finally, we define naught factorial as being 1.